Hello. So, in this presentation, we will discuss classes in Python. So, classes is a very important abstraction in programming. It helps in creating large codes. It abstracts programs in a better way. Okay, so I will illustrate with some examples how classes help making large codes. So this is called object-oriented programming. So as name implies, so we don't think of program as data types like integer, or float, strings, but we think of big objects. For example, I can think of a vector field, so which has arrays, in fact, 3 arrays. Vector field will have 3 arrays, and also associated functions of the vector field, like curl, divergence. So let's look at another example, simpler example. So think of designing a large apartment complex. Yeah, architect is thinking about large apartment complex. You don't expect the architect to think of bricks and mortar, right? Architect has to think freely about this big building. So what does the architect think of? Thinks of. So he or she thinks of floors, um, which way it will be oriented, how wide should it be, okay? Apartments inside the floor. I mean, how many apartments do we have in a floor? Okay. Connecting pathways, okay, stairs, elevator. So these are all objects. They have nothing to do with the bricks and mortar and walls. No. So this is an object. Apartment has walls, bricks, but it is combination of many things. So it's a bigger abstraction. And the floor is an abstraction which is even at higher level than apartments. Right? Pathways are connecting the apartments. So these are how we think of large codes. Large codes will have various components, big components. Okay, so if I kind of automating an institute, then we think of departments, directorate, classrooms. So you're not thinking of strings and integer, and so we don't think like that. It turns out with modern programming languages, not modern anymore because they are around for several decades, C++, Java, and Python too, allow this object-oriented programming. We can create objects. C++ is the most advanced language for object-oriented programming. Python objects are not that powerful as C++, but we can create certain level of abstractions in Python itself. That's what I'm going to illustrate, how to construct objects in Python. So it is not as as advanced as C++, but reasonable idea we can get from Python objects. For this course, at least, we are not getting into big details or advanced programming on object-oriented programming. So one more point you should think of it is a multi-scale or hierarchical structure. So as I said, apartment has rooms. So we have, let's say bricks is the most bottom level. Then we have rooms, then apartment, then floor. So you see that when you keep going up, it's getting bigger and bigger. Okay, and the whole apartment, whole uh, building, which has many apartment complex. Okay, so this is hierarchical. It's levels of scales, large scale, then smaller, and even smaller, like that. Similarly, large codes are created hierarchically. So let's look at one example. So I want to create a program for simulating thermal convection. So what is thermal convection? We have a container where we heat from the bottom, heating, and there's a fluid inside, which gets hot. And of course, after some time, if the temperature is, I mean, if it's heated strongly, then there are convection, there are currents which happen like that. So the velocity field moves like that. Okay. So this is called convection, which you've seen it. If you take a kettle and heat from the bottom before boiling, well, normally we see this boiling stuff, but before boiling, there is certain water currents. Anyway, this is a problem. Now, of course, we can write a Python code, C code, where we have arrays for the velocity field, right? We create arrays. Then the size of the array, and there are functions for time stepping, nonlinear stuff, and so on. It turns out, if I think like this, it's too messy. I had to have three arrays, and I need to think of how to uh, make a divergence of the vector field, so which is u1, tx, dy, u2, and so on. Right? It is cumbersome. Okay. However, I can think of this problem in terms of fields. So we create a class called velocity field. So velocity field has three components: ux, uy, uz, and all of them are arrays. Then I can define how to curl of this vector field, divergence of a vector field. Okay, so all this can be defined, and when I assemble it later, okay, for time advancing the velocity field, I will use some of these objects. So, for example, I want to compute divergence, and I just simply call this divergence of u. Okay? So u dot grad, u. So I can create this. I can create a function nlin for a vector field u. We create how to compute. This is a function of u. Okay? So once I create this library, then my thinking for the full solver becomes simpler. So I already have this set of tools with me. Okay, then I think, okay, I need to time advance. So velocity field at t plus delta t. It is all position. Okay, so velocity at t plus delta t times nlin. So I'm thinking of this as a vector. Okay. Instead of writing this, I'm doing it for ux, ui, uz, then nlin is very complicated object. So we prepare yourself at different levels, and also we have large team, a team with maybe 100 programmers. So some programmers may be asked to do this. Somebody will say, well, you create this divergence operator, okay, like that. So this is a good thing to prepare. So this is like your one level of objects. So here you see you have variables, which are arrays, and functions. By the way, this for the velocity field. Now we can create similar objects for scalar field. So we have temperature T. Then I can define various functions. For example, grad T. gradient of t. Okay, Laplacian t. So you can create operators for all of them. And so class will have field and its associated functions. And so thinking about these functions make your life easy. You can write your code like a physicist or like an engineer, so you don't need to worry about integer, float, no need. Okay. And the code is cleaner, less error prone. So these are the advantages of object-oriented programming. And it turns out these codes are fast too. I mean, it's not that we sacrifice by making objects. The performance is equally good in terms of speed. Okay, so let's think of, I'm going to give some illustrations how to make classes in Python. We'll keep it simple. We are not going to solve convection problem today. But if you know these ideas, then you can easily construct those objects. Not a big deal. Okay, so Python, in fact, is everything is object in Python. So it is object oriented in some sense. So Python function, Python arrays, Python variables are objects, as we discussed earlier when we dealt with immutable variable, mutable variables. So everything, when you say x equal to 5, this 5 is an object. Or when you say x equal to y equal to 1, 2, 3 list, so this is an object. Okay, so Python is not only keeping the number 5, is also keeping some other stuff along with 5. So it's an object. So anyway, so let's now create an object in Python. So in today's lecture, we will create a class, not a vector class for the velocity field. It's a simple class called student. So this is the name of the class. By the way, there is no student yet. This is a definition. We don't have a student. Say there's some abstract entity called a student who has a name and roll number. Okay. My present example is not a very good example, but we'll create a better example in the next slide. So right now I'm giving a name to the student, hard coded name, Arjun, and roll number 1. Okay. It is not, so this is just, in fact, is poor example. So I'm just giving an example. So we create we are defined, this is a class definition. This is not a creation of an object yet. Right now, there's no student. This is a definition. Like we have function. I'm not executing a function. My function definition. Okay. So when I execute it, then I'm executing the function. Similarly, here I have class definition. And so this is a 3-line. So the class has structure which has 2 fields. One is name, which is a string, and the roll number, which is an integer. Now I instantiate. This is called instantiation or creation. So I create a student S1. Okay, S is for student, first student called S1. And this S1 student has a name, which is Arjun. Okay, name is Arjun. And S1 dot roll number is 1. This is the 1. So once I create this, instantiate it, then there's a student in the class. So we have only one student in the class right now, whose name is Arjun and whose roll number is 1. Okay. So, it's a very simple class, which is only variables. But so we define a class and we instantiate a class. Okay. Please note that this student S1, the name of the student is not S1. S1 is a class. So this is not a name. Okay. So the output is, so when this is a function, well, this is a file. When I run this file, then in Colab, we just click that arrow. When I run it file, then I say Arjun 1. Why? The print is a usual Python function. S1 dot name is Arjun and S1 dot roll number is 1. Okay. So please keep in mind that S1 is an object. So see, for example, in Python, when I say 5, it's an object. It is not integer. Its value is, when I say, well, you would have something called value inside. Its value is 5, which is type integer. Okay. So name of the object and fields inside the object, they are different things. Right? We'll make it, I mean, in the next few slides, we're going to show you how to create a function associated with the object. Okay, you just wait for a while. Okay, now we are, in fact, we right there. So there's a init, in fact, is a function. Okay, what does it do? It assigns value to the object variables. Okay, so some object has a variable, for example, a student has a name and has a roll number. So the init function will assign those stuff in the definition. Okay, so initialize the class. In fact, it can do some more stuff, which we will not discuss it in today's lecture, but it can do some more stuff than just assignment. Okay. So init is called whenever, so this, in fact, this function is called every time a function is instantiated. For example, I had said S, so I had S1 is student, right? That's what I had said. So this instantiation, and it was called that time. And this init will be called. In the earlier example, I had no init. In the previous example, here I had hard coded the name, which is not a great thing, because I want another student, then every student will have name Arjun. Okay, so it's not a great thing. So we want to create an object where I can give different names and different roll numbers. Right, that's what we want. So we have very generic class definition. So we have, so this is a class of student. Now it has some fields, which is name and roll number, like before, but it will be assigned by the user or by the program. So this init is a function for initialization. It takes inputs. These are arguments, name and roll number. Okay, when I instantiate it, I'm going to give this stuff, name and roll number. Now, there's a new thing called, well, there's something slightly weird called self. Okay, this philosophical thing, who am I, the self. So we keep this self, and the self has certain usefulness. What is usefulness? So I want to say, well, this student has a name, right? So how do I call that name? So earlier when I had student S1, then I had said S1 dot name. So S1 was already created. Right now I have not created this S1. Okay, so that's where the self has come. Self is myself. Okay, so it says, well, so myself dot name equal to name. By the way, this could have been something else. Okay, I could have put name 1 and name 1 here, but it's better to keep the same. Convenient actually. It's not necessary. So this is name 1 and this name. So the key, well, basically the name of the variable is name and roll number, which is part of the student. Okay, so student has basically student has these two fields. These two fields. But how do I access it when I define the function? While defining it, it is a self.name. Because right now, this generic, any student, so for every student, you say, well, self, yourself, dot name. And what does it take the value? It takes value name. Then self dot roll number, it takes value roll number. Okay. So this is a function definition right now, a class definition, not function definition. Within that, there's a function init, but init is a very generic function. In fact, this for initialization. Init is, in fact, it's a acronym for initialization. Now I instantiate it. So how do I instantiate S1? S1 equal to student Arjun 1. Okay. So now I am giving, so this Arjun, this one is passed here. And 1 is passed here. Okay. So S1 is a student now. So earlier I had just written student. It didn't require an argument in the previous example. But now I need to give arguments. The arguments are name and the roll number. Okay. And I can say print S1, name, roll number. I create a new student S2 equal to student. So let's get some lady name. So let's call Mary. 2. So this is second student whose name is Mary and whose roll number is 2. So I can create as many students I want. And later I can get some interaction among the students. Okay. Or I can assign grades to the students, CPI to the students, and graduating year. So we can do lots of stuff once the objects are created. Okay. So this is a simple function init. And by the output of this file, when I execute it, is going to be Arjun 1. It's printing S1.name and S1.roll number. Right? Now self. So let's, I'm just repeating what I just said. Self is a parameter, is a reference to itself within a class. Okay. So right now name is, so there's no student per se when I define the class. There's no concrete student. So it's well say just abstract student, the self. You just use yourself dot name. You use to access the variables of the class. Okay, like name and roll number. So this is what I did before. So this example has one more new thing. So S1 I had instantiated here, Arjun 1, but I can change the name. Okay, let's say for some reason the student wants to change the name. So this is going to come in the record, S1.name. It's a new name, Dhananjay. Okay, Arjun, is in Mahabharata. His name was also another name Dhananjay. So I just gave that name Dhananjay. And now print. So what will it print now? Here S1.name. Will it print Arjun or will it print Dhananjay? So this name has been replaced. Arjun will be replaced by Dhananjay. So that it will print Dhananjay, not S1. Not Arjun, sorry, not Arjun. Or neither S1. So I'm going to come to that later. This function is not there yet. So S1 not roll number. Okay, so Dhananjay 1. So this is the print of the name. So it turns out the self, we wrote self, no? It can be any name, any arbitrary name. It doesn't matter. All of them will work fine. So here, instead of self, I replace by anything. Okay, so just say anything. So anything name, roll number. So by the way, this is not being passed. You see, when I create a student, I have only two arguments, Arjun and 1, they go here, argument 1 and 2. Argument 0, anything is for self, but it could be anything. So it's anything, but you have to call this anything dot name is name and anything dot roll number is roll number. Okay, so this self is not a keyword per se, but at least we can use any name. But this one should be same as what I have it here and here, and it has the same effect. Arjun 1. All right. So class variable can be modified. I think I already explained that before. So the name is a field, okay, and name I can say s1 dot name is Dhananjay. I could also change the roll number, s1 dot roll number as a 10. Okay, so then when so the new roll number will be 10. Presently it is changed name in Dhananjay 1. Okay, so that's how we create a class or define a class and instantiate a class variable. So this is a new function called str. So it returns a string representation of an object. Okay. So when I say print, so if this x variable x equal to 5, so print x will print 5. Okay. However, if I have a class s1 is a student is with argument, how about printing s1? Is it possible? But the s1 is not integer or float, it has name and it has a roll number. So how will I print s1? I mean, the Python is confused. What should I print? So string so this function comes to help. We can create its identity. So method returns string representation of an object. You can choose what you want to print. So print s1. Okay. So this is just to declare yourself. So I can call this by print or str function. So let's look at it here. So this part is same as before, init, but this part is str. But what I'm returning, whether this f is for formatting. Yes, is formatting. Self name, which is name of itself. So self is an argument here. Has roll number. So this is string, which is going to be printed when I say print s1. So print s1, what is going to print? Name has roll number. So this is formatting, and formatting takes this argument as a variable will be within curly braces and stuff like that. Okay. So, and you can print this stuff with print s1 or print string s1. So this is what I got. Arjun has roll number 1. But the string has within quotes. Somehow this is not coming, but string has this within quotes. It's a string, so it will create that. So it's useful if you want to print an object. Okay, with bigger object you can print it. Okay, so there's another function called pass. Well, it's not a function per se. So variable we have none. When I say x equal to none, that means this variable x is empty. Similarly, you have empty class, but you can't say just empty. So you have to say pass. So pass is okay, nothing. So student pass, and so basically it means empty class. So we can't print anything, we can't assign anything. So this is an illustration, but sometimes useful, but in general you can ignore it. Okay, so let's take a break. In the next slide, I'm going to explain about inheritance, which is an important concept in classes.